Then we go to transaction 2, B is equal to B plus temp. Then we write B. Okay, here in this schedule, T1 is same as the before T1 and in the previous schedule, and T2 is also the same as T2 in the previous schedule, but the order of operation here is different. T2 just executes two operation, then we go to T2 and we execute 5 operations of T2, then we go to T1 and executes 4 operations of T1, and then go to T2 and execute 2 operations. So here the order of execution of operation is different from the previous schedule. Let me call this schedule S4. Okay. S4 is also concurrent schedule. We can make this this meeting public, that any person can join it, and do not ask me to admit. Can we make?
It must be, Doctor, it must your agreement.
Can I convert this meeting to a public meeting that do not need my permission, do not need my admission? I'm not familiar with.
Maybe there is no option about this.
Okay, there is no option. Okay, let's continue. Okay, this schedule S4 is another concurrent schedule. Okay, let check if this schedule is consistent. At first, A suppose is 1000, B is 2000, and A plus B at first is 3000. Okay, T1 reads A. A here is 1000. Then A is minus by 50, so here A is 950. Okay, but this value, this 950, does not write, has not written on the database here. So when Tido here reads A, he sees the previous value of A, and A is 1000. A is still 1000 because T1.
Is that because we didn't write A?
Yes, because T1 does not write A. Okay, so A on the database, A is still the previous value. Okay, so when Tido reads A, it sees the previous value of A, which is 1000. Okay, then temp will be 100. Okay, then A is minus by temp. A will be 900. Sorry. Okay. Then A is written on the database. So here the value of A on dB. The value of A on dB is 900. A on dB is not 900. Tito reads B. The value of B has not been changed still, so the value which is read is 2000. So B is 2000. Okay, then we go to T1. T1 here wants to write A. Which value is written on A? The value that T1 has computed before, 950. Okay, not 900. The value of 900 in Tito is 40 do. T1 does not know that value. T1 uses its own value. T1 reads A. A was 1000. Then he minus 50 from A, and A became 950. So for T1, T1 is 950. Okay, so when he write A here, A on dB is written, the value that is written on A on dB is 950 here.
Doctor,
Yes, please.
in the T2, we write the value on database on 100. Yes.
Yes. When we write the value of 900 on the database, okay, because T1 does not read A, because T1 has read A before writing A. T1 has the old value of A and do not know anything about the new value that T2 writes on DB. Okay.
No. Okay. Thank you, Doctor.
So T1 works with its old value, with the value that it reads before. Okay. Okay. So A for T1, the value of A is 950, and when he writes it on the DB, the value of 950 is written on the database for A. Okay, here as you see, T1 and T2 interfere each other and corrupts the works of each other. T1 writes on DB the value of 900 without noting that T2 has written the value of 900 on the database. So these two transactions corrupt the effect of each other and interfere, and because of that, we see at the end of this schedule when the consistency does not hold. Let me continue. Okay. Then T1 read A. Which value T1 reads? The last value that is that B has. The value of B is 2000. So here what T1 reads is 2000. Then this value is added by 50, and T1 writes B. So the value of B on database will be 2050. Then we go to T2. T2 wants to add temp, wants to add temp to B. What value of B? The previous value that it has read. I mean 2000. So here B will be 2000 plus temp. Temp is 100. So the value of B will be 2100 here. Okay, then this value is written on the database. So
sorry, doctor, this transaction is isolation or not?
no, it is the isolation here does not hold. Okay.
Okay.
Because DBMS should not allow data transaction interfere each other. The DBMS should not allow corruption of the effects of the transaction by each other. But here, as we see, this is not the case, and transaction interfere each other and corrupt the results of each other. So here, isolation does not hold. The value of B on database is 2100. Okay, the last value of B on database is 2100. The last value of A on the database is 950. A plus B will be 950 plus 2100, and it will be 3050. Okay, this means that $50 have been created in the bank. So we do, so this schedule is not consistent. Is not consistent because the consistency condition does not hold here. So
please.
Yes, please.
Doctor, please, in the first transaction T1,
Okay.
the last value of written B is 2050. Then when
Yes.
we call the B in the second transaction, it will be
Okay.
2050 plus temporarily.
No, it is not the case because T2 does not know anything about the values that T1 has written on the database, because T2 has read B before writing B by T1. So T2 sees the previous value. T2 sees 2000 value, and here works with the value that he read before. Okay, T2 does not know that between these two operations, between reading B and changing B, T2 assume that no transaction no transaction changes the value of B. So if he worked with the value that it read before here, he read B and B is 2000. So this transaction work by the value that it has read before. So it works by the value of 2000. Suppose suppose that every transaction has the memory space of itself. Okay, you can consider that A and B is local variable in each transaction. So A in T2 is different from A in T1. A and B in T2 are local variables, and A and B in T1 is also local variables, and T1 does not know anything about T2, and T2 does not know anything about T1. If a transaction writes on the database, the other transaction does not know that changes, except the second transaction go and read the database. If we read the database, we see the change. But if we do not read the database, we do not see the change. Here, T2 read B before this writing, so that's the change. T2 does not see the changes. Okay.
Okay, Dr. Clear. Thank you so much.
Okay.
So, Doctor, excuse me.
Yes, please.
Now, when we make a summation for A plus B, we choose 950 plus 2100. Why we didn't use the first one? I mean, 950 plus 2050.
Okay.
Why we choose the 2100?
We should see the last value on the database for A and B. Okay. As you see here, we do read A, then the second operation from T1, and then we go to read A from T2, and the first write on A is this, which is 900. Okay, so the first value that has been written on A is 900. Then if we continue, we reach to this write A by T1. T1 write 950 on A. So the previous value, which was 900, is changed to 950. So the last value that is on A is 950. Okay. After that, we do not have any write on A. So the last value, which is on A, is 950, and if we read A, if we see A, the value of it is 950. But about B, the first write on B is here. The first write on B is here by T1, which writes 2050 on B. Then we come to T2, and the second write on B is 2100. So the last value of B will be 2100, not 2050, because after writing 2050 on B, we next write 2100 on B. So the last value of B is 2100. The last value of A is 950. Okay, because we first write 900, then we write 950. So the last value on A is 950. The last value of B is 2100. So if we sum these values, we
Thank you so much.
have 3050. Okay. Okay, let's continue. Hope, as you see, do you understand Persian or not? Do you prefer to teach in English or in Persian?
English,
In
doctor.
English,
In
English,
English,
doctor.
Very good. So
Yeah,
Doctor,
because
English.
we just passed the first course in Persian.
okay, so we see that
Thank
you learn Persian very well and you prefer
of God
to
will,
use English.
doctor, of God willing.
Good,
Okay,
doctor. Sure, inshallah.
Inshallah.
in the future, inshallah.
Inshallah.
Okay, so you see here a concurrent schedule that is not consistent because the order of execution of operations are not good. So if we would like um, if you would like to not have these situation, this state, and if we want to have if we want concurrent schedules be consistent, we should control the order of execution of operation. I mean DBMS should control the order of execution of operations. It cannot be arbitrary. We should control it. If we do not control the order of execution of operations, we do not have consistency. If we would like to have consistency, DBMS should control the order. As you see in the previous schedule, the order was good, so we have consistency. But here the order is not good, and we do not have consistency. So DBMS should control the order. Should control the order in a manner by some algorithms to ensure consistency. This is the responsibility of DBMS. If DBMS does its responsibility, we also have isolation. Here we do not have isolation because these operations interfere each other and corrupt the results of each other. But DBMS should force isolation property. If DBMS control the order of execution, isolation is also hold. Okay. So, in brief, we know that every serial schedule is consistent. So, serial schedules are important and have an important property, which is consistency. Every serial schedule is consistent. But about concurrent schedules, we are not sure. What we can do? What we can do for concurrent schedule to be consistent? One idea is that we uh, we run and we execute operations in concurrent schedules in a similar way to a serial schedules. I mean, we run operations of concurrent schedules such that the concurrent schedule will be equal to a serial schedules. So if we have concurrent schedules that are equal, or here we say that uh, equivalent. If a concurrent schedule is equivalent or similar to a serial schedule, then we can show that the result will be consistent. So we define the concept of serializability. Sorry. I'm not very familiar with this environment. Okay. Serialize ability. Serializability is different from serial. It's not equal to serial. We have serial schedules that you saw before. The transaction is executed. Transaction are executed one after each other. But in serializability, we have concurrent schedules that are equal to serial schedules. So we define the concept of serializability.
Could you repeat, please, Doctor?
Please repeat again your question.
Could you repeat what you said?
Yes.
Your voice is gone.
Yes. We have
Please.
serial schedules. Okay, you saw this concept before. Serial schedules are schedules that a transaction is executed, then another transaction is executed, and then another. So every transaction is executed after other transaction. But by serializability, we mean concurrent schedules that are equal to serial schedules. A serializable schedule is not serial, it's concurrent, but is equal to a serial schedule. So in the following, we are going to define this concept, serializability. What is serializability? Serializability. We define two types. We define two types of serializability: conflict serializability, and view. Serializability. We have two types: conflict serializability and view serializability. In the following, we are going to define these two types of serializability. Okay. Let me first define conflict serializability. Which is conflict serializability? Conflict serializability is defined based off a conflict of operation. Or conflicts of operation. Conflict of operations. What do we mean by conflict of operations? Two operations have conflict if the order of their execution is important. We have read operation, okay, read operation and write operation here. By operation, we mean read and write. We have read operation, we have write operation. Okay, we want to know what operations have conflict. We say that two operations have conflict if the order in which the order in which the operations are executed is important, or we can say the final result depends on the order, or the final result depends on this order. Let me explain it, but by example. Suppose we have sorry. Okay. Suppose we have two transactions. Ti and transaction Tj. Suppose transaction Ti read a data item, for example, data item Q, or account Q, for example. Read a data item from database, data item Q from database. Then transaction J reads data item Q from database. Okay. Is it important that what transaction reads first and what transaction reads second? For example, if here transaction Tj reads first and transaction Ti reads second, does the final results differs in these two order, or they are the same? Is it important or not? If Ti reads Q, for example, if Q has the value, for example, 1000, if Ti reads Q, he sees that the value of Q is 1000, then Tj reads and it sees that the value is 1000. In this in the other order, if at first Tj reads Q, the value is 1000, and then Ti reads Q and sees that the value is 1000. So is there any difference between these two order, or is it important that which transaction reads Q first? You can answer.
Sure, it's important.
It is important.
Yes.
What the difference between these two order?
In the past example, if we will write the or we will
No.
choose the
Do not consider right. Just do not consider right. Just think that we want to read. Okay, transaction Ti and transaction Tj want to read. No right. Okay, do not consider right operation. Just read. For to read operation, is it important that which transaction read first and which transaction reads second, or not?
Doctor, while the same value not have matter to the order.
Yes, it does not matter. Okay, it is not important because both values reads the same both transaction reads the same value. in both order. Okay, so it is not important in which order this transaction read Q. So we say that two read operation does not do not have conflict. Okay, read and write operation, read and read. Excuse me, two read operations. Two read operations do not have conflict. Do not have conflict because in both order, in any order, they read the same value. It does not matter. It is not important. But for read and write, we cannot say the same thing. For example, consider one transaction wants to read and the second transaction wants to write. Ti, Tj, also here the other order, Ti, Tj. In the first order, assume that Ti reads Q, and then Tj writes Q. In the second order, in the right side, suppose that first Tj writes Q, and then Ti reads Q. Is the result does the result differ in these two order or not?
Sure, now it's surface. Because we'll read the another amount. Maybe we'll get another results, and some information maybe will be lost. Right?
Here, suppose that these two transactions just suppose Ti just needs to read Q and Tj just wants to write Q. Okay, suppose the value of Q at first is 1000. Okay, in the left side, Ti read Q. What value it reads?
1000.
The value which is read is 1000. Okay, but in the right side, because Tj writes Q, the value of Q on database is the value that Tj has written on Q. So when Ti reads Q, the value of the value that it reads is not 1000. It's the value that Tj has been written on Q. So these two order does not have the same effect and may result in a different may result in different different result, different final result. Okay, did you got the point?
Could you repeat this point, Doctor, please, again?
Yes. If Ti read Q and then Tj write Q, Ti does not see this write and reads the previous value of Q. But in the right side, because Ti read Q after writing Q by Tj, so Ti reads the value that Tj has written on Q. Okay. But in the left side, Ti reads the original value of Q. These two orders are not the same. Did you got the point?
Yes, thank you.
They differ from each other because in the left side, TI does not see, does not read the value that TJ writes, because the write of TJ is executed after read. So this read operation does not see the effect of this write. But in the right side, because first TJ write Q and after that TI read Q, so the TI sees what TJ has write and the database. Okay, the value that TI reads in the left side and in the right side differ from each other. So these two order is not the same. Okay, so for read and write operation, so read and write operation have conflict. Read and write. Operations have conflict because the order of execution of these two operations by two transactions is important. The final result is not the same. Okay. What about to write operation? If two transaction wants to write TI, TJ. TI wants to write Q, and TJ also wants to write Q, but TJ writes Q after TI. In the right side, suppose the order is in reverse. First, TJ writes Q, and then for both orders, the final result is the same or not. Is the order of execution to write operation important or not?
Not important because the same value, doctor.
Oh, we do not know. It's the same. Maybe
Actually, it's effect. It's conflict. Actually,
maybe the value that TI wants to read differ from the value that TJ wants to read, because the computation in TI and TJ are different. Maybe the value that TI wants to read is 10. The value that TJ wants to read is 20. Okay. Maybe Q.
yes. So it's effect because doctor,
Maybe Q
the
is 20
will take
here
the last
and
value,
Q
right?
is 10 here. Okay. If we assume that Q is 10 here, but is 20 in T2 in TJ. If TI writes first and then TJ writes, the last value of Q here will be 20. But in the right side, if TJ write, the value of Q is 20 first and then rewrite by the value of TI, which is 10. So the final value would be 10. Okay, did you got the point? Is it
Please
clear?
repeat it, doctor.
Suppose TI wants to write the value of Q, which is 10. Okay, the value of Q is 10 in TI, and wants to write Q. The value of Q is 20 in TJ, and TJ wants to write the value of Q. In the left side, TI first writes and then TJ writes. In the right side, in the write schedule, TJ first writes on Q and then TI writes on Q. I ask you if these two different orders, are have the same result on the database or not. As you see in the left side, first the value of 10 has been written on Q, and then the value of 20 has been written. So the final result will be 20. The final result, the final value that you see for Q on database is 20. In the right side, first 20 value is written on Q, and then 10 value is written on Q. So the final value of Q is 10. So as you see, the results are not the same in the left side and in the right side. So the order of execution of write operation of writes operations are important. Okay, is it clear? Did you got the point?
Yes, Doctor.
Yes,
Clear.
it's clear.
Okay, so we
Thank
say that because the order of write operation is important and is not the same, the result is not the same, we say that the two write operation have conflict. So we say in total, in brief, in summary, we say two operations have conflict if the order of their execution is important, and the result, the final result, differs for these two orders. Okay. As you see, two read operation do not have conflict because their order is not important, but read and write have conflicts. So we can summarize this in a table. Suppose, oh, sorry. Oh. Okay, suppose we have TI and TJ. TI, TJ. If TI wants to read Q and TJ wants to read Q, we do not have conflict, no conflict. If TI wants to read Q and TJ wants to write Q, we have conflict. Yes, there is
no conflict.
conflict. Also for write Q by TI and read Q by TJ, again we have conflict. For write Q by TI and write Q by TJ, again we have conflict. So only for two reads we do not have conflict. Read and write, write and read, write and write have conflict. And the order of execution and the order of their execution is important. If we change the order of their execution, the result is not the same, and then the order of their execution is important. So we say that they have conflict. Only two reads operation do not conflict. Do not have conflict. Okay. Also note that if two transactions read different data item, for example, if Ti and Tj work with different data items, for example, suppose Ti read Q and Tj write P, a different data item. When Ti works with Q and Tj works with P and data items are different, is the order of execution important or not?
Not important. It is
Not important,
not
because they do not affect on each other. Okay, because this is this transaction read Q and that transaction write P. There is no relation between these two data items, so the order of their execution is not important. So when the data items are different, we do not have conflict. Okay. If the data item is the same, for example, Q and Q, and if we have only read, we do not have conflict. But if we have a write, for example, read and write, write and read, or write and write, and the data items are the same, we have conflict. So for different data item, for different data items, we do not have conflict. We do not have conflict. Okay. Any question?
Doctor, we can say that the conflict is occur when the operation is depend on each other, right?
Yes. We have conflict if the operation affect each other. Yes, and this occurs when data items are the same, and at least one of the operations are right. If data items are different, we do not have conflict. If data items are the same, but both operations are read, again, we do not have conflict. But if data items are the same and one of the operation is right, then we have conflicts, as you see. Okay. So if we uh, change, if we change the order of execution of two operations that do not have conflict, the result will be the same. For example, if we change the order of execution of these two operations, the result is the same. Okay, it's not important which one is executed first and which one is executed second. If two operations do not have conflict, we can change the order of their execution, we thought changing the final result. The final result will be the same, because the order of their execution is not important. But for operations that have conflict, we cannot say the same thing. Here, these two operations have conflict, so we cannot change the order of their execution. If we change the order of their execution, the final results will be different. So we are not permitted. We do not have permission of changing the order of execution of operations that have conflict. We do not have this permission. We should maintain the order. We should not change the order of the operation that have conflict. But we can change the order of operations that do not have conflict. For example, here, read P and write P, we can change the order of their execution without changing the final result. Also for two read operations. Two read operations do not have conflict, so we can change the order of execution without changing the final results. We have permission. We have permission to change the order of execution of these two operations because they do not have conflict. Okay, it's enough for this session. In the next session, we continue this discussion. If there is any question, please let me know.
Excuse me, doctor.
Yes, please.
I have one question about the research you requested. When we need to complete this research and presentation, and do we have, if we can, to find the research for database and big data, these things, data mining, or we have just in database?
Okay. For your presentations, you should have two presentations. The second presentation should be a paper. That you find and read. But the first presentation, for the first presentation, it is not required to read a paper. You may read some parts of a book or some text from internet. It is not required to be a paper. But the second presentation, for the second presentation, you should read a paper. This is one point. The second point is that the content of this presentation may be anything about data. Database, for example, database itself. For example, different types of database. For example, about SQL database, MySQL database, SQL Server database, Oracle database, and so on. It can be about discussions that we have about the subjects that we have in this course. For example, concurrency control, recovery, transaction management, and so on. Also, it may not connected directly to database. Anything about data can be considered for presentation. For example, data mining or IoT or mobile database, data warehouse, data lake, and so on.
Big data.
Okay. It
Okay,
may
thank
be,
you, Doctor.
it may be about, for example, privacy of data, security of data, anything that is related to data. It is not needed that directly be about database. Please
Okay.
search and find some subjects, then send me and let me check. If it is okay, then you can go and read the context, the content that you have found, and prepare a presentation. But at first, you should search some contents on the internet and send me to check them. If it is okay, you can continue and read that content and provide your presentation.
So, Doctor, send it to your email.
Yes, send me an email when you find a content that is that is related to this course for presentation. Send me that content and let me check if it is okay. If then if it is okay, you can go and read the content and provide your presentation. Yes, send me email. Yes,
Thank you, Doctor. Doctor, I have another concern actually,
please ask.
please, about the over classes. So, you know, we are traveling each Friday from Iraq to Tehran, from Tehran to Iraq. So we are traveling. Most of us, they are traveling on Friday.
Okay.
So that's maybe we'll lost this class actually, and
We
we don't
can.
need
Oh,
and we
okay.
don't like to lost any class.
Okay, we can schedule another time on Friday. Which, for example, which o'clock? Which o'clock is okay for you on Friday? Uh, as I know, all of you are busy and muazzaf in uh, the days of the week.
Yes.
So the only days that we can schedule the sessions are, I think, are Monday, Thursday, and Friday. On Monday, also some students have Persian language classes, so we have only Thursday and Friday. On Thursday,
Actually,
this time is